Okay, now let us calculate the limiting radius ratio for other coordination numbers, which is a continuity of the part 1. So the cubic lattice, which is having a coordination number 8. So here the anions are in the corners of a cube and the cation will be at the center. The anions are touching each other and as well as the cation. The edge of the cube will be equal to twice the radius of the anion. So here is the anion. So this is the edge and this is the radius of this anion and this is the anion. So the edge of the cube is said to be 2r minus. So here when you are considering this to be a cube in which in the corners the anions are actually occupied. So this is the cube which is occupied by the anions in the corners, the top 4 and at the bottom 4 in the corners, and in the middle you have the cation, and this cation is in contact with the anions and each anions are also in contact, that is in the edge. So here this is the one edge, the two anion. And the longest diagonal, so here is the one, the longest diagonal. So the longest diagonal, you could see this one, which is actually going through the two anions as well as the radius of the two anions as well as the cation, that is the diameter of the cation, the distance. The distance of that longest diagonal is the summation of the radii of the two anions as well as the diameter of the cation. So this is actually found here in this figure. This is the one, this anion passing through the cation and touches this anion. So this part and this part. And we have this and we depict this separately here. So for calculation purpose, you take that and you have this arrangement. Okay. So this is A, this is B. So let us just label here. This is supposed to be A, this is B, C and D. Similar way here it is A, B, C and D. So you take that A, B, C and D. So this is the edge we have seen, this is 2r minus. Similarly here also this is two anions touching 2r minus, and here also it will be 2r minus. This is the one. So the diagonal which is passing through the cation and touching the edges, so here is that cation. So the diagonal distance is 2r minus plus the diameter of the cation, 2r minus plus 2r plus. Now we are going to calculate the r plus r minus. So we take this let me rub this part. So here is the one. So this is A, B, C and then D. This distance, sorry, this edge is 2r minus. Okay. Now in triangle, so you take triangle A, B, C. So this is the one, A, B and C. In this triangle, using the Pythagoras theorem, you just derive AC square is equal to AB square plus BC square. So this is the one, AB square plus BC square, that will be equal to AC square. Then AB square, it is 2r, isn't it? 2r minus. So 2r minus you have just assumed to be B. So let us take B square. Similarly, BC square is also 2r minus. So again it will be B square. So that will be 2B square. Then AC will be root 2B. So this is in triangle ABC. The next in triangle A, C, D. So this A, C and D, this part. So you take that part, then you see In triangle ACD, according to Pythagoras, AD square is equal to, that is the one, AD square is equal to here AD square, AC square plus CD square, AC square plus CD square. So AC we know already, therefore AD square is equal to AC square. From here you take this, that is root 2b plus CD square. From the diagram it is the edge length, so 2r minus, that is b, we need to consider that to be b. 2r minus, we are taking it to be b, so that will be b square. So here AC is this one, but what about AC square? AC square is 2b square, so here you just substitute 2b square. So 2b square, that will be 3b square. Then AD is equal to root 3b. Now what is AD? AD is this part, 2r minus plus 2r plus. So 2r minus, so here you could see this is the one, AD, 2r minus plus 2r plus, so plus 2r plus, that is equal to root 3. Now you substitute for b, that is 2r minus. This is the value for the b. Now you just simplify, 2r plus 2r minus plus 2r plus divided by 2r minus, that is equal to root 3. Then 2 will be removed, then you get r minus r plus divided by r minus, that is equal to root 3. Then 1 plus r plus by r minus is equal to root 3. Then r plus by r minus is equal to root 3 minus 1, and the value is supposed to be 0.732. Therefore, r plus by r minus for coordination number 8 is 0.732. Hope you understood this one. Okay, 0.732. So let us move for the next coordination number. So here is for the hexagonal close packed structure with the coordination number 12. So the cation is supposed to be here. It is actually surrounded by 1, 2, 3, 4, 5, 6 and 7, 8, 9, and above one more hexagonal close packed structure will be there, in which the 3 anions will be present here. So totally 12 will be the coordination number. So in this case you could see, so here if it is the vacant site, if it here is a vacant site, so this is the one, it is surrounded by 1, 2, 3, 4, 5, 6, and here it will be 1, 2, 3, and similarly if another structure is above this one, this also will have the anion, the 3, so 1, 2, 3. So totally you have 12, 6, 7, 8, 9, 10, 11, 12. Now let us just for calculation purpose leave that below and the above anions, only which are present in that plane we will take this one. So this is the cation and the remaining 6 anions are touching the cation. Now you take the triangle you just take the triangle ABD. It is an equilateral triangle, so the angle is supposed to be 60 degree. So in triangle ABD, so what is AB? AB is the summation of the radii of anion as well as the cation, that is r minus r plus. And what about BD? BD is R minus. What about BC? BC is 2R minus. Okay. Now in this triangle ABD, using trigonometric function, you take cos 60 degree. Cos 60 is adjacent divided by hypotenuse. What is adjacent? Adjacent to 60 degree. Adjacent to 60 degree BD, and which is the longest hypotenuse, that is AB. So you write adjacent will be BD, hypotenuse will be AB. So what is BD? BD is R minus. What is AB? AB is R plus R minus. Okay. Now what is cos 60? 1 by 2. Then R minus R plus R minus 0 point, otherwise you take the reciprocal. 2 is equal to R plus R minus divided by R minus, then that will be 2 equal to R plus by R minus plus 1, then R plus by R minus is equal to 2 minus 1, therefore R plus by R minus equal to 1. This is for the coordination number 12. Hope you all understood. So for hexagonal close pack with the coordination number 12, that is for close packing structure, R plus by R minus will be 1. So here is the summary, which is actually depicting the radius ratio values, coordination number, expected structural arrangement, and the examples of the ionic compounds. If the expected radius ratio is 0.155, the coordination number will be 3, expected the structural arrangement will be triangular, so mostly the boron oxide will be possessing this. And if the coordination number is 0.225, then you could see the coordination number should be 4. Tetrahedral arrangement, mostly zinc sulfide, which has 2 ionic structure pattern, woodsite and zinc blend, beryllium oxide, zinc oxide, etc. If it is 0.414, coordination number, it is 6, octahedral, and sodium chloride, potassium bromide, magnesium oxide type TiO2 will be showing this one, coordination number 6. 0.732, coordination number 8, cubic arrangement, cesium chloride, and then calcium fluoride, and coordination number 1, the radius ratio is 1, then the coordination number will be 12, so it will be cube octahedral close packing, so mostly the metals will be possessing, so beryllium, calcium, cobalt will possess HCP, and silver, aluminium, gold will be possessing CCP. Hope you all understood. Do remember the radius ratio value so that you can correlate with the coordination number and the possible structural arrangement. Thank you.